Hello everyone, so we're starting out this unit, right triangles and trigonometry, with dealing with the Pythagorean Theorem. Now I know it's something we've worked with in the past to find the distance between 2 points, but here we're just going to be looking at a couple different examples. So remember, in order to use the Pythagorean Theorem, it needs to be a right triangle. Okay? No other type of triangle we can use the Pythagorean theorem with. It needs to be a right triangle. So remember the parts of a right triangle. A and B, these are both called legs. And then C is our hypotenuse. C is our hypotenuse. Okay, and we always know it's the hypotenuse because it's opposite the 90-degree angle. Okay? So, when I've got a right triangle, the Pythagorean theorem states that if I square the legs and I add them together, that will equal the square of the hypotenuse. So, a squared plus b squared equals c squared. And the parts of these, a and b, are the legs, and c is the hypotenuse. It's got to be set up in that order. All right, so in example 1a, we've got a right triangle that has a hypotenuse length of 2 square roots of 3 and one leg with a length of square root of 3. What is the length of the other leg? So I will always recommend, my friends, that you set up a diagram. Okay, so I'm going to draw a right triangle here. Okay, I'm actually going to move it up so I can label things. We know that the hypotenuse is 2 square roots of 3. So I'm going to label the hypotenuse as 2 square roots of 3 because it's opposite the 90-degree angle. And one leg has square root of 3. So it doesn't matter which leg here. I'm just going to label it as square root of 3. And we're trying to figure out the length of the other leg. So I'm going to call that x because we don't know it. Okay? Now, when I'm dealing with radicals in the Pythagorean theorem, I want to use parentheses. Because when I set this up, I'm going to do x squared plus the square root of 3 squared equals my hypotenuse squared, which is 2 square roots of 3 squared. Use parentheses. All right, now let's simplify these. Let's square what we can. So, square root of 3 squared is the same thing as square root of 3 times the square root of 3. So multiply what's underneath the radical, and I would get square root of 9, which equals 3. Okay, so square root of 3 squared, that's going to act as the squaring undoes the radical, the square root. So I got x squared plus 3 equals, well, now let's figure out what 2 square roots of 3 squared is. So that's going to be 2 square roots of 3 times 2 square roots of 3. That's why we need to use parentheses, so that we know we are squaring the entire 2 square roots of 3. The number outside and the number in front. So 2 times 2 is 4. Square root of 3 times square root of 3 is square root of 9. So this is going to be 4 times 3, which is 12. Okay, so we get x squared plus 3 equals 12. So now I'm going to run out of room a little bit, but I'm going to subtract 3 from both sides. So I'll get x squared equals 9. Oops. Square root of both sides, and we'll get x equals 3. So x equals 3. 3 is the missing leg. So that's how you deal with setting up a diagram and using Pythagorean theorem, especially with radicals. You want to make sure you're using parentheses so that you're actually squaring the appropriate things. All right, go ahead, pause the video, try out B. We'll go over B in class. All right, I'm gonna do this as a you try now. I'm going to move on to part C. Okay, so in part C, we've got a triangle within a triangle. Now, it's very, very common for students to want to use Pythagorean theorem on this triangle here. Okay, but the issue with that is that this angle right here, not a right triangle. Not a right triangle. Okay, so I cannot, so x squared plus 39 squared does not equal 60 squared. We cannot set that up because that's not a right triangle. So instead, what I like to do is set up the two right triangles that we have. Notice how we've got a right triangle symbol here. So I've got this small triangle here. And then we've got the big triangle. Right? So let's draw them separately. Let's not all mess it up on one diagram. So if I draw the small triangle, that would be 36 is this leg, 39 as the hypotenuse, because that's opposite the 90-degree angle. And we don't know this bottom leg. What about the big right triangle? So we've got the big right triangle where we know one of the legs is 36. The hypotenuse is 60. And then part of the bottom leg is x, but we don't know the other part. Well, notice this other part here is the same thing as the bottom leg in my small right triangle. So, what if I labeled this bottom leg y in the small right triangle? If I labeled it y, well then we can solve for that part of the big bottom leg. 36 squared plus y squared equals 39 squared. So when I simplify that and get y squared by itself, so I got 36 squared, which is 1296, plus y squared equals 39 squared, which is 1521. When I subtract 1296 from both sides, I get y squared equals 225. When I take the square root of both sides, I get y equals 15. So I know that this part here is 15, which means that this part here is 15 in the big right triangle. Okay? This missing side length here helps us figure out that the entire bottom side length in the big right triangle, what do I have to do with x plus 15? Well, part plus part equals whole. So this is going to represent x plus 15. So now we're still trying to solve for x, right? We're slowly getting there. But now that I've got this big right triangle, and I know that this is x plus 15, let's set up Pythagorean theorem again. We have 36 squared plus the other leg, which represents x plus 15 squared. And here we need parentheses, equals my hypotenuse squared, which is 60 squared. Okay, so 36 squared, we already know that from the last problem, that's 1296. Plus, now here is where we got to be very careful. Because remember, x plus 15 squared, and I'm running out of room, so I'm going to throw it over here. X plus 15 squared is the same thing as x plus 15 times x plus 15. We need to make sure that we're multiplying the binomial by the binomial. So then, when it's x plus 15 squared, we got x times x, which is x squared, x times 15, which is 15x, 15 times x, which is 15x, and 15 times 15, which is 225. Then when I combine like terms, I get x squared plus 30x plus 225. And then that equals 60 squared, which is 3,600. Okay, let me zoom in here because we're focusing now on solving this equation. Combine like terms. So I'm going to get x squared plus 30x plus 225 plus 1296. That's going to be 1,521 equals 3,600. So I'm going to subtract 3,600 from both sides because I'm dealing with a quadratic. So that's minus 2,079 equals 0. And I can factor this now. All right, I don't know the factors of 2,079 off the top of my head, so I'm going to use quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac. Oops, I'm running out of room. Come on. All over 2a. So I'm going to simplify this. Underneath the square root, I'm going to get 30 squared minus 4 times 1 times negative 2,079. I'm going to get 96. So the square root of this whole mess. So negative 30 plus or minus 96 divided by 2. So when I do these separately, I got x equals negative 30 plus 96 divided by 2. And x equals negative 30 minus 96 divided by 2. Got to split it up to do both of them. I'll get x equals 33 and x equals negative 30 minus 96 divided by 2, negative 63. Okay, now remember what x is talking about. I know it's been a long problem, but x is talking about a side of a triangle. Sides cannot be negative, so I want x equals 33. Okay, so problems like that, yes, they are a lot of work. You're using Pythagorean Theorem a couple times. You've got quadratics in there. Some things to really make sure you're paying attention to. You cannot do x squared plus 39 squared equals 60 squared. It has to be a right triangle. All right, and the other part that we need to make sure we're doing is x plus 15 squared correctly. All right, this is not x squared plus 225. You're missing the middle term. So please, please, please do not distribute the squared. You need to multiply the two binomials together. Okay, so I know that's a long problem. Very similar to something you may see in your homework, quiz, or test. So definitely want to make sure you understand how to break this problem down to use the Pythagorean Theorem a couple times and make sure all your algebraic steps are correct. Okay? Again, practice those problems on the homework. Let me know what questions you have. Last concept for this video, Pythagorean triples. Pythagorean triples are a set of three integers that satisfy the Pythagorean Theorem relationship, which is a squared plus b squared equals c squared. All right, so these are just some numbers that you should be able to recognize and automatically know that they satisfy a right triangle. Because like 3 squared is 9, 9 plus 4 squared is 16, 9 plus 16 is 25, and 25 is 5 squared. So all of these triples satisfy the Pythagorean Theorem. Now, notice, what is the pattern? We got 3, 4, like pattern in the rows. We got 3, 4, 5, then 6, 8, 10, then 9, 12, 15. The second and the third row are just multiplying the first row by a number. 3, 4, 5, 6, 8, 10. Well, that's 3, 4, and 5 multiplied by 2. So that's something else to help you out with. First row times 2. 3, 4, 5 becomes 9, 12, and 15. If I take the, not first row, first column. If I take the first column here and I multiply it by 3, I'll get everything in the third column, right? If I take 5, 12, and 13 and I multiply it by 3, I get 15, 36, and 39. So if you need to kind of memorize or understand any of them, understand this first column, because then if you understand those, then you'll recognize the multiples in the other columns. Okay? So it's just Pythagorean triples exist and are there to help you recognize the Pythagorean relationships so that you don't necessarily always have to do a squared plus b squared equals c squared. Like if you see your legs as 3 and 4, you automatically know that that hypotenuse is 5. Alrighty? So that's going to wrap it up for this video. We've done a lot of problems. Make sure you go back and do letter B and pay attention to the next video for the last concept with Pythagorean theorem.